Now that we know how to calculate angles using the special angles triangles, so now that we are equipped with calculators, we will learn how to use a calculator to compute the angles. Okay, so very important before we go and do any exercise. Note that this arc sine, this sine exponent -1, it is not the same as 1 over sine. Okay, so this sine to the -1 like this, it is a reciprocal function, and this 1 over sine, it is a reciprocal ratio of cosec. So the value of sine of this one, we call this one arc sine. The value of arc sine and the value of this reciprocal ratio are not the same, so do not confuse them. So yeah, don't confuse them. So it's like this. It's like if I say this one, this arc sine is an arc sine. It is used when we want to find what? When we want to find an angle. And then for example here we'll say opposite over hypotenuse. So here we'll put in a number, you know, opposite over hypotenuse. This is when we use this arc sine. And then also we can have another scenario whereby we can have this, the sine of theta, and then to the -1. So this thing and this one and this thing, they are not the same thing, because this thing is the same as 1 over sine theta, and it is not the same as this one, because as you can see, this one inside the bracket does not have theta, but this one is sine theta, you see. So they are not the same, so do not confuse these two things. So always be aware. So we'll only use the arc sine when we're trying to find an angle. Sometimes you'll see that other textbooks, they say theta, it is equals to arc sine opposite over hypotenuse. If we wanted to find an angle using a cos, we are going to say arc cos of what? Adjacent over hypotenuse. And then for tan, we would say the tan of, we can say arc tan, or yeah, arc tan of opposite over adjacent. So what is this arc function that I'm talking about? So let me open a calculator here. So if I want to select this arc function, I must press shift and then I choose whichever function that I want to use. So for example, I have tan. I want to use tan, and then I see that, okay, so if I want to use tan, and then I see that opposite over adjacent, my opposite is 1 divided by 1, and then I want to see how much will be my angle, and then here's what my angle will be. If I press equals to, I can see that the answer is 45. Okay, I can also use this with a sine. If I say arc sine of 1 over 2, so arc sine of 1 over 2 gives me what? Gives me 30 degrees. You see, this is how we use the arc sine function. Alright, so let's do an example. So in example 1, they say in triangle PQR, angle Q is 90 degrees, and then side Q is 12 centimeters, and side P is 4 centimeters. Find the values of angle P and angle R. Okay, so they told us that angle Q is 90 degrees. So this tells us that this is a right angled triangle. Okay, so as this is a right angle triangle, we are going to use our trig ratios. Alright, okay, so you will notice that we have a capital letter Q and a small letter q. A capital letter Q represents an angle, while a small letter q represents a side. Similarly, even with P, capital letter P represents an angle, while the small letter represents a side. So if we were to write another side, it will be small letter r, this side. Okay, so they want us to find the values of angle P and angle R. So how are we going to do that? So we can see that, oh, okay, we have this value and that value. So if this is a right angle triangle and we want to find angle R, so if I'm looking at angle R, I can see that, okay, then this is a hypotenuse to side to angle R, and this one will be adjacent to angle R. So I have adjacent and what, and hypotenuse. So which trig function that give us adjacent and hypotenuse? So it's cos, because remember from so ka to wa shosha ka. So we are going to say angle R, it is equals to, okay, so because now we are trying to find this angle, we are going to say arc cos of what? Arc cos of what? Of adjacent over hypotenuse. What is adjacent? Adjacent is P, hypotenuse is Q. Okay, so now we can see from here that we will have 4 divided by 12. Okay, so let's press the calculator and see how much we are going to get. So the shift in cos, 4 divided by 12. Okay, so it says the answer is 70.52, I think, yes. Oh, 0.53. So round off your answers to 2 decimal places, 0.53, and then there it is. There we have 70.53 degrees. So now how can we find angle P? How can we find angle P? So we have two angles. We have an angle here, we have an angle there. P, we can find it using the interior angles of a triangle. We can do that. We can also find P by using sine, because if you look at P, if we rotate this triangle, you can see that for P, then we will have opposite over hypotenuse, you see. So meaning that now angle P is going to be the arc sine of opposite over hypotenuse, which is P over Q, and then arc sine of 4 over 12, and then the answer would be okay. So now the answer is what? Is 19.47 degrees. Okay, so let's see if this makes sense, if these answers are correct. Remember that the sum of interior angles of a triangle must add up to 180 degrees. So let's say 19.47 plus 70.53 plus that 90 degrees of a right angle. Let's see how much they add up to. So they add up to 180 degrees. So it's correct. Okay, so now we are going to learn how to solve these two-dimensional problems on triangles. So you will see that most of the time, if you have a triangle like this, you will see that you have an angle named with a capital letter, and a side opposite to that angle will be named with a small letter of that angle. You see, as you can see, C, capital letter C for angle, and then small letter c for a side. Alright, so let's have an example. In example 1, they say calculate the length of BC. The length of BC. So, with respect to this angle and this side, now BC, I can say that BC I can use tan because this would be opposite this angle, this side would be opposite this angle 50, and then this one would be adjacent to that. So I would have opposite over adjacent, so which is tan. So I would need to use tan. So this is the relationship. I would say tan of 50 degrees, it is equals to BC over 4 centimeters. Okay, so BC over 4 centimeters. So now remember, I want BC, so I need to cross multiply. So if I cross multiply, I can see that this one is a denominator, so a denominator will multiply the numerator. So I will have 4 multiplied by tan 50 degrees, it is equals to BC. Okay, so now we go to our calculator, we press that 4 multiplied by the tan of 50 degrees. Okay, so always when you use a calculator, make sure that here it's written D for degrees, so that you don't use the radians and end up getting incorrect answers. Okay, so it says that now, therefore BC is equals to 4.77 centimeters. 4.77 centimeters. What about AC? They say we must calculate AC. So now, if I'm looking at this angle and I want AC, so while using trig ratios, I can say this side is the hypotenuse to this 50 degrees, and then here I can see that this AB is adjacent to this 50 degrees. So adjacent to hypotenuse, it's what? It's cos. So I can say cos of 50 degrees, it is equals to adjacent, which is AB, divided by hypotenuse, which is AC. So now remember, I want what? I want AC. Because of I want AC, here's a trick. So here I need to cross multiply. So if I want to cross multiply, what am I going to do? If you want something that is in the bottom like this, and then you want it to make it subject of the formula, what you need to do, you just swap it with this one. We take AC, we put it there, and then cos 50, we put it at the bottom. So we'll say AC is equals to AB divided by cos 50 degrees. So, and then now we substitute AB, which is 4, divided by cos of 50 degrees. Let's see what is the numerical value. So we're going to have 4 divided by cos 50. So it's 6.22, I think. Yes, 6.22. 6.22 centimeters. So as you can see that AC is the longest side compared to the other sides. So this would tell us that this is the correct answer. Alternatively, here's what you could do. Remember that you got BC after using tan 50, you got BC, and then you could have used Pythagoras theorem to find AC. Okay, so let's go to example 2. So in example 2, we have another triangle, excuse me. So they say now if angle C it is equals to 90 degrees, calculate the size of angle B. So they are saying now this is a right angled triangle, and then the 90 degrees is here. So if the 90 degrees is here, then for us to calculate angle B, we look at angle B. Where is angle B? Angle B is here. It's here. Okay. So now we can see that AC is opposite to angle B, and then AB, it is an hypotenuse to angle B. So here's what we do. We are going to say we are going to use sine, because sine is opposite over hypotenuse. So we are going to say remember that we are trying to find an angle. We are going to say angle B is equals to arc sine of what? Of AC divided by AB. Okay, so from there, and then we can say, we do that to substitute AC, it's 3.4 centimeters, and AB is 7.2 centimeters, and then we go on to press the machine there, and then we can see that arc sine of 3.4 divided by 7.2. Okay, and then what is the answer? You can see that the answer there is oh man, I pressed sine, should have pressed arc sine. Okay, arc sine of 3.4 divided by 7.2. Okay, so it says that the angle is 28.18 degrees. 28.18 degrees. So that's it. Okay, let's check another question, another example, the last one. So now in triangle PQR, tan theta is equal to 5 divided by 12. Tan theta is equal to 5 divided by 12. So now remember, tan is opposite over adjacent. So this side PQ is opposite to theta. So it means it's going to be 5. And then over adjacent. This QR is adjacent to theta. So it's going to be 12. So we have that. So and then they say calculate angle theta. So now from what was given to us, we can say then theta, it is the same as arctan of 5 divided by 12. So and then we can say therefore theta it is equals to, and then we say now arctan of 5 divided by 12. We get 22.62 degrees. 22.62 degrees. Now let's go to cos theta. Now with cos theta, they just want us to substitute the theta inside the cos. So and then we continue there to say the cos of 22.62 degrees is equals to cos of 22.62 degrees equals to 0.92. Alright, so and what about the length of the hypotenuse? So we can just use Pythagoras there and say PR squared, it is equals to PQ squared plus QR squared. So now PQ is 5 squared plus QR is 12 squared. So remember that here it's PR, it was PR squared. So if I want to remove this square, I must introduce a square root both sides. So I must introduce a square root this side, then a square root the other side. So I will have PR is equals to the square root of 5 squared plus 12 squared, so which is 13. Okay, so we can see that PR it is equals to 13. Okay, thank you guys. I hope you do this and practice. These are just the basics, so that you can go and do more challenging things, but having smaller basics. Okay, thank you. See the next video.